Hello everyone, hope you all are doing well. So today we are going to do topic 37, that is water use efficiency in relation to crop production. Water use efficiency in relation to crop production. So we will be dealing in this topic in two sessions, that is 37A and 37B. So today we are going to start topic 37A about water use efficiency. So what is water use efficiency? It is the ratio between effective water use and actual water withdrawal. Effective water use and actual water withdrawal. So what this means? So how much water we are withdrawing and how much effectively using of the withdrawal water. So that is water use efficiency. It is also defined as yield of marketable crop produced per unit of water used in evapotranspiration or water used in field. In evapotranspiration or water used in field So it is of two types. First one is crop water use efficiency. It is ratio of crop yield. Crop water use efficiency is ratio of crop yield. Why is crop yield? By to water depleted by crop in evapotranspiration. To water depleted by crop through evapotranspiration. So what crop water use efficiency is? Ratio of crop yield to water depleted by crop. How much crop depletion of water is done by crop through evapotranspiration. So this is crop water use efficiency. Now second is field water use efficiency. It is the ratio of crop yield by water used in field. Field water use efficiency is ratio of crop yield. Why is crop yield by water used in field? This is WR. So I hope you all understand what water use efficiency is and what are its types. Now moving on, what is water distribution efficiency? Actually in previous years they asked both the terms, so I must explain you both the terms. What is water distribution efficiency? Water distribution efficiency. It is also denoted as ED, efficiency of distribution. It is the measure of uniformity of water distribution in field. Measure of uniformity of water distribution in field. So how uniformly we have distributed water in the field? Suppose this is field and this area is high in water content and this is low, so it suggests it has a low water distribution efficiency. If the water in the field is evenly distributed, then it has high water distribution efficiency. It represents extent of water which has penetrated to uniform depth throughout the field. When water is penetrated, this is penetrated uniformly throughout the field from mean depth is 0, then water distribution efficiency will be 1. So what is water distribution efficiency? It is 1 minus y by d. What is y? Average numerical deviation. And what is d? Depth, average depth into 100. So what it is? 1 minus y by d into 100. This is water distribution efficiency. Y is the deviation. Suppose this area has high, this is low, so we need to calculate the deviation, and d is depth. So I hope you all understand what is water distribution efficiency is. Now moving on, what are the factors influencing water use efficiency? Next topic of the session. Factors influencing water use efficiency. First of all is that high yielding cultivars have high water use efficiency compared to traditional cultivars under similar management. That is high yielding cultivars or crops have high water use efficiency compared to traditional cultivars in same management, because they are stronger they use high yielding varieties, use high amount of water, so their water use efficiency is high. Ideal climate during crop growing season is major factor for high water use efficiency. If the condition will be ideal, the crop will grow nicely, and if the crop will grow nicely, it will use maximum amount of water in highly efficient way, so it will have high water use efficiency. All the agronomic practices aimed at high yield will contribute to high water use efficiency, because for high yield we will do good agronomic activities like good fertilizers, good manuring. So what it will do, it will enhance the crop to use the water efficiently and give the highest of our yields. Water use efficiency also depends upon physical and chemical properties of soil, such as acidity, alkalinity, waterlogging, and reclamation. To these problems increase water use efficiency. So when you reclaim these problems, reclamation of these problems will significantly increase water use efficiency. So these are some of the factors which impact water use efficiency. Now moving on, what are the management factors or ways to improve water use efficiency? management factors / wage to improve what management factors or what ways you will apply to improve water use efficiency. The first one is efficient water management practice. Such as localized irrigation method, irrigation scheduling, deficit irrigation practices, improving the irrigation efficiency, irrigation water pricing, conjunctive use of water resources, reduce evaporation, how can we reduce evaporation? Example by mulching, reduce runoff and percolation losses. So these are things through which we can improve water use efficiency. This was water management practice. Now moving to second one, that is crop management or agronomic practices. We can also increase water management practice by efficient crop management or agronomic practices, such as selection of better crops and cropping system, a good cropping system will enhance water use efficiency, proper tillage, proper fertilizer use, as we have read in factors that good agronomic practices always enhance water use efficiency. The proper fertilizer use will enhance it, proper weed management, mulching, as I have discussed just earlier, use of anti-transpirants that will reduce evapotranspiration or transpiration, amelioration or reclamation of problem soils, better interaction of other inputs or all other inputs. So these things will lead to good increase our water use efficiency. Now moving on, what is water productivity? Water productivity. It is defined as crop production per unit volume of water used. Crop production per unit volume of water used. It can be done by three ways, that is water productivity per unit evapotranspiration, that is water productive unit evapotranspiration. What is this? It is mass of crop production divided by total mass of water transpired by crop. That is mass of crop production divided by mass of water transpired by crop. Mass of water transpired by crop and lost from soil. So this is of three types water production. So this was the first one. Now second one is water productivity per unit irrigation. This is here crop production is divided by irrigation flow. Crop production divided by irrigation flow. The third one is water productivity per unit gross inflow. This is water productivity. It is crop production divided by rain plus irrigation flow. Crop production divided by rain plus irrigation flow. So I hope you all understand how we can calculate water productivity. These are the three ways what water productivity is. Now moving on, what are the types of soil water? Next topic of this session, types of soil water. So what is soil water? It is found naturally in soil. Water found naturally in soil. It is of three types. First one is gravitational water. Gravitational. What is this? It is the free water. It is free water moving through soil by the force of gravity. By the force of gravity. It is largely found in macro pores of soil. Largely found in macro pores of soil, and very little gravitational water is available to plants, and very little gravitational water is available to plants, as it drains rapidly down. The water table. In all except the most compact of soils. In compact soils, it doesn't rapidly come down to the water table, but in normal soils it rapidly goes down the water table, and it is influenced by gravity, and hence very little is available to plants. Now the second one is, I hope you all understand what gravitational water is. Second one is capillary water. It is held in micropores. It is held in that one macro, MA, this is MI, macropores of soil. And the water, and is the water that composes, and it is the water that composes the soil solution. Capillary water is held in soil because of because the surface tension properties what is are these surface tension property? That is cohesion and adhesion. Of soil macropores are stronger than force of gravity. Hence gravity is not able to pull this water to the table. Okay. However, the soil dries out, the pore size increases, and gravity starts to turn capillary water in gravitational water, and gravity starts to turn capillary water into gravitational water, and it's moved down. So what happens here? When the soil dries, the pore size increases, that is, the pore size becomes from micropore to macropore, and the gravity starts pulling this water. Hence the capillary water changes itself to gravitational water and moves down to the table. I hope you understand what capillary water is. Now moving on to the third type, that is hygroscopic water. It forms a very thin film surrounding soil particles. And is greatly not available to plants. This type of soil water is bound to so tightly to soil by adhesion properties that very little of it can be taken by plant roots. The adhesion is here so high that plant roots are not enough to absorb or extract or pull this water. Since hygroscopic water is found on soil particles, and not in pores, certain types of soil with few pores, it is not found in pores. So certain type of soil with few pores, with less pores, will contain high percentage of hygroscopic water. Which type of soil? Example, clay soils, which contains few pores. So I hope you understand what hygroscopic water is. So that was all for today's session. The remaining parts of this topic I will deliver you in the next session, that will be topic 37b. Hope you like the video. Please press the like button, do share and subscribe, and for any queries do comment. That's all for today. Have a nice day. Thank you.